So welcome to Global Summit, first in-person Global Summit in quite a while. This is an introductory session into what our data platform is actually all about, or what data architectures could be all about. So I see some faces that I recognize that for whom this will be common knowledge, but I'm hopeful that it will still be inspiring or give you a broader perspective at the platform. If I may ask, any people for whom this is their first Global Summit? Okay, great. Then you're in the right place, because this is actually an introduction right for you to talk a little bit more about what data architectures can be and what how a data platform takes a holistic view at data architectures and helps you solve them in a very cost-efficient manner. So I'll be in this talk, I'll be walking through a realistic customer scenario to point out what a data architecture could evolve to look like. And by reviewing some of the goals of the different actors in this scenario, we'll see how this puts very different requirements on a data architecture. So the agenda for today is actually fairly simple. I'll first talk a little bit about that data architecture and build it up through a couple of people that contribute needs to the platform. Then we'll talk about a platform itself, and then I'll talk about a couple of customers of ours, some of whom are attending and others who we thankfully have as our customers. And that implemented some of the use cases that I'll be talking about in the first piece. But first, let me share something personal. My kids love crafts. And now you're probably expecting me to boast, and they're so creative, and I love my kids so much, and they make these beautiful things, but none of that. If you are a parent who has kids who are primary school aged, you'll probably know what I'm talking about. So the creative crafts project also always has two phases. There's the first phase in which they watch these 5-minute craft videos on YouTube. And the 5-minute part is the first big lie, because they watch it for hours on end. And I don't know if anybody has seen some of these videos, but they typically feature kind of a camera face, filming hands that are taking boxes, old shoe boxes, plastic bottles, paper, cardboard, and then those hands, you see them cutting up the thing and then gluing it back together, taping it back together until it looks like something that, yeah, it looks kind of nice but isn't really super useful. So that's the first part. The second part is the kids trying to do it by themselves, which is obviously great. You don't want to refuse them this great creative session. You don't want to refuse them and it must be also a very sustainable form of entertainment, because they're reusing trash, they're reusing old shoe boxes, they're reusing discarded plastic bottles. There's only a couple of shiny things that are added to the mix, and they can't be too hard to get by, can it? So why would you possibly refuse them this chance of this personal development that will undoubtedly turn them into great architects, designers, entrepreneurs, and whatnot? So I'll tell you what is a bit of a problem there, or at least what is kind of a problem for me. So here's the catch. The catch is the glue. If you have kids like me in this situation that love crafts, you'll know that there is a glue budget. So our family has a glue budget, and you'll know that there are things like a shiny type of tape that's called washi tape. There is glittering glue for the glue gun. There is shiny Pritt stick that shines at sticking to the kitchen table rather than shining or sticking anywhere else. And so all these things together, they contribute the cost. They make up the cost of all of the crafts enjoyment. So my employer, InterSystems, pays me enough to foot the glue bill, but I think you can probably share or feel that frustration that all of the money is being spent on keeping stuff together rather than on quality stuff itself. So that's kind of a personal frustration that I wanted to start with. That's not very good from a drama theory point of view to start on a negative, but anyway. So I'll just continue to ignore these and carefully hide their masterpieces until they've faded out of memory enough so that they can be disposed of without too much drama. Okay, on to the real subject, managing data. So today we'll look at some of the challenges in data management architectures. And by data management architectures, I mean the combinations of technologies that together solve a goal, that together address the needs of a group of people. And the group of people that we'll be talking about is in a hospital because, well, we're at InterSystems and we have a fair number of customers in that industry. Let me first also introduce you to two people that are going to coach us on this journey. So you can see Data, the data engineer, and Cindy, the cloud architect. These people are highly experienced professionals, and they'll be full of great advice for us. When I'll speak for Cindy, I'll be talking a lot about AWS. Not because I'm a particular fan of AWS more than all of the other ones, but I still don't know how to pronounce Azure. And there's still other choices. And we're in their hometown, so why wouldn't we do it? Anyway, there's plenty of other cloud service providers that have amazing solutions that are the equivalents of what I'll mention. On to the story. So here is Nuri. Nuri is a nurse. Nuri works at a hospital, and she admits patients. So she's in the emergency room, entering the initial patient's observations. So that means that Nuri is sitting in front of an application, and she's entering patient details. There's going to be some checkboxes. There are going to be some drop-down fields. There's going to be some free text fields, all kind of regular information for a patient that goes into lists or goes into a database. So that sounds like a relational database kind of thing. Hopefully, it's going to be a relational database that supports transactions so that you can enter all of the pieces of the patient in one transaction, because if you have to enter pieces separately, that's not very good for the patient. And then Dan will come and tell us, Dan, the data engineer, will come and tell us that he knows a ton of options for this. There's a lot of enterprise databases, but he knows he can get us a bargain by offering us solid open source solutions. Like MySQL has been around for a long time. Postgres has an even better reputation than MySQL. So there's plenty of good solutions out there in the relational database market. Cindy, our cloud architect, also has some advice. So she can deploy an Amazon RDS instance for us, which has the same feel as an instance that you would install on-prem, but it's managed in the cloud. Or she proposes Aurora, which has a fully serverless feeling, which is also great because it takes away some more of the pressure. Okay, so that's what Nuri does. She enters initial patient observations, and then she needs to dispatch the patient to a ward somewhere in the hospital. Now, preferably, she kind of maintains a bit of an even distribution across wards. And for that, she can look in the relational tables and check which ward currently has the least patients. That's great, that's easy, that's still something our relational database is really good at. But then maybe it would be great if she could also know upfront whether the ward is going to be empty tomorrow. So just looking at the current state of the ward occupancy is maybe not enough to have a clear picture of where would be the optimal place for assigning patients to. So this is where our next friend comes in. This is Doug, and Doug is a data scientist. So a data scientist takes data, for example, from a relational database, such as our EHR, and then uses it to try and predict a particular attribute that is of interest. In this case, it would be great if Doug could help us predict how many patients are going to be discharged for every ward, so that Nuri can take this into account when she admits a patient and make sure that they get sent to the ward that is not only the emptiest one today, but also going to remain emptiest, just to make sure that we kind of aim for an even distribution of patients amongst the wards. So that's what Doug does. He takes data, he wrangles the data a little bit, and then puts it into his tools. So Dan, our data engineer, has some great advice. He says that he can export it to a file, and then he can load that file up into their Python environment so they can use XGBoost, scikit-learn, and all those other wonderful libraries that he has experience with. Super easy, super efficient. Now, Cindy, our cloud engineer, has some other ideas. So she has, for example, she suggests that we export the data into an S3 bucket and then make it available to AWS SageMaker, which is a great machine learning as a service platform. So that platform can go and pick up the data and give you the predictions, and you can export the model and put it back in, and she can take care of all of that with a little bit of consulting help. Sounds great. So with this model built in, Nuri can predict how many patients are going to be discharged for every ward, and she can kind of aim for an even distribution in the reasonably near future. So that's what Doug does. Now here's Fiona. Fiona is a physician who works with Nuri to help assess the state of a patient in the emergency room and helps diagnose that patient and decide on an initial treatment plan. Now, like some of you, I live in Belgium. Belgium is a very small country, but it still is a country with more than one hospital. It is a country with more than one hospital and one physician, which means that there are going to be more than one place where patient data is available. So even if you live in a tiny country with very few clinicians that have actually access to a computer, you'll find that your data is horribly spread around different systems. And it is obviously interesting for Fiona, in order to be able to decide on the treatment plan, to know more about you, to know, for example, if you have allergies, because that is quite essential to make sure that you're not ending up in a worse state than you were in when you walked into the door or were wheeled into the door. So for this information, as many of you who attend this conference will actually know, that information gets exchanged between different systems through networks such as health information exchanges in formats such as FHIR. FHIR is a JSON-based language, which means that it's JSON documents that contain a nice model, a very detailed, very fine-grained model to express patient information that can be passed between different systems in a kind of standardized way. So we're talking about a very important capability or a very important need to be able to take in and transform and read that JSON data, those document data, those FHIR documents, and be able to integrate them with the information from our EHR. No problem, says Dan, the data engineer. Dan has an acquaintance who's worked with CouchDB or MongoDB, who are both very well-known document databases that can do this job. And that acquaintance also happens to be a consultant that specializes in this. And so they can build all that integration because, well, those databases don't really have specific FHIR support, but they're really good at their document storing job. Cindy, the cloud engineer, says, no problem at all. You don't have to install anything because we have Amazon Document DB, which is up in the cloud, super efficient for storing, querying, and transforming JSON data. And actually, it's closer by your EHR, and we have something called Amazon Glue that can convert between these two data formats. So we're done with that use case as well. We've satisfied that need as well. So the next person in our hospital is Catherine. Catherine is the CFO, and as it turns out, running a hospital is not cheap. So it's Catherine's job to make sure that the hospital remains profitable. So she wants to see information about where money is being spent. So she wants to look at information that comes from some of the systems that we haven't yet talked about, such as the procurement system, the finance systems, etc. So that's how that's how money is being spent at a hospital. Now, about the income of for a hospital is a very complicated picture that probably several of you know much more about than me. But most public hospitals, they are funded by the government or by payer organizations, and they get compensated, or their funding is based on how well they are at curing patients. And that is expressed through quality metrics. And you could say that the goal of a hospital is to get people out as quickly as possible. So then the ideal scenario would be that as soon as they are admitted, you keep them for a day and then you send them home and assume that they will be cured. That's not really how it works. Readmissions is what happens when people get discharged too early and are then readmitted within a certain time period for the same thing that they were actually already admitted for in the recent past. That is very costly. That's very unpleasant for the patient, or very unhealthy for the patient, but also very costly for the healthcare system. And that readmission rate is a very important quality metric, although a negative one, for the hospitals. So that is, of course, also very important information for Catherine to have access to be able to minimize readmissions. So that means that she doesn't only want to see the stuff from a financial dashboard, but she would also like to see some of the clinical data that feeds into or that talks about discharges and readmissions. So that means we need kind of a combination of data coming from one system, coming from another system, from our EHR, and we don't want to disturb Fiona and Nuri when they're going about their business, so let's make a copy of that data and put it into a data warehouse. Data warehouses are nothing new. Data warehouses have been around for a long time, hence Dan has some suggestions for us. He's got a friend who works at Teradata and can get us a really good deal. Teradata is one of the best known platforms for data warehousing, and they can also make sure that all the data flows are taken care of properly. Cindy will also have some suggestions, for example, Amazon Redshift. Amazon Redshift is a well-known data warehouse as a service that's proven itself in the market, and it's actually close by because it's in the same cloud, so you don't have to pay ingress or egress if you're lucky. So we're in a good position, and Catherine will have all of the information that she wants in her data warehouse, and probably in Cindy's example, she can also propose Amazon QuickSight, which is immediately the dashboards that she's looking for. With her love for fine-grained details, she'll also appreciate the invoice that she's getting from AWS. And then, all right, we still have Dr. Phil from the intensive care unit, who has just purchased a few dozen all-in-one monitors. So these are monitors that monitor patients and then get their vital signs. And actually, last year he also made a nice purchase from the same friendly firm for syringe pumps. And these two can be integrated. They give detailed information not only about the vital signs, but from the syringe pumps they can also get the information of exactly how much was injected into the patients, and some feedback from that. So that kind of device, that kind of medical devices, is a great source for another category of data. That is data where there's a very important time component to it. Exactly the moment when it was administered, exactly the moment when the heartbeat was measured, etc. So that's time series data. Time series data is relevant to the hospital for yet another reason, not only for being able to give patients the best care, but in Dr. Phil's example is that he's actually not just working with that firm, but he's also working with a university hospital or with a university that wants to do some research and wants to study the impact of particular medications on the vital signs and the actual path to recovery for the patients. And that is interesting because participating in those kinds of clinical research projects is another potential source of income for the hospital. So this is certainly something that Catherine will think is worth investing into. So she calls Dan and Cindy, and Dan proposes TimescaleDB. TimescaleDB, well-known platform for handling time series data, which actually has some shared ancestry with Postgres. So if we chose Postgres for our EHR, then there will be some small pieces in common in the technology stack as well. So can't be too hard to integrate those. Cindy will propose Amazon TimeStreamDB, which, as you guess, is a fully serverless auto-scaling solution for ingesting time series data. So that sounds great. That sounds like we've satisfied all of the needs for all the people that work in our hospital. We've got technology that suits all of them. So are we done now? So by now we're down to a data architecture like this, a typical Belgian house. If you don't believe me, go to uglybelgianhouses.com and you'll find pictures of great Belgian houses. So we have assembled an impressive array of technologies that are best of breed, that are great fits for exactly what we wanted. And with all of those combined, we find ourselves with a staggering number of technologies. And we had actually some luxury to pick from multiple possible candidates at every step in the road. And in certain cases, we also had the opportunity to pick open source things, such as the Postgres that I mentioned. For TimescaleDB is also Postgres. So the license cost is not too big. So what do we find ourselves in now? We find ourselves in a situation where we have a lot of quite affordable components that we're putting together and for which we actually come up with a rather fancy solution that looks really good, but then maybe it's not really what we're looking for. So we find ourselves with very affordable ingredients, a couple of shiny special purpose things. So all we needed to do was to glue them back together, shall we? So we're back in the 5-minute crafts story that I started this conversation with. So for these kinds of architectures, it's the glue and it's the tape where the budget, that's where the budget is going. In the Amazon case, it's actually literally called Amazon AWS Glue. So it's those little bits of code, all those scripts that are representing the biggest cost of these kinds of best-of-breed approaches. And they need to be developed by the Dans and the Cindy's of this world. And what's worse, they also need to be maintained by Dans of Cindy's in this world. So as soon as Dr. Phil comes up with new syringe pumps, then you need to kind of re-engineer the whole thing to make sure that also that stream goes into first the time series database and then into the EHR, so it can be paired up with data for Duck to build some nice models with. So those 5-minute craft videos, they only talk about the creation part, which is the fun part. They don't talk about the maintenance. They don't talk about how long it lasts before things break down. So this maintenance is typically kind of the maintenance cost is typically an order of magnitude higher than the initial cost of setting things up. But they're a great source of income for service integrators, of course. And then another aspect that is also not to be underestimated is the effort it takes and the energy it takes to purchase from all of these different organizations. So having like half a dozen suppliers is already quite a burden to maintain. So could we accomplish things differently? Let's first sum up where how we came here. So we started off with a relational database to satisfy the needs of Nuri, the nurse, to get that EHR up and running to kind of store all the relational data. Then we combine that data with data from finance systems and other systems into a data warehouse. So that's a different style of databases, often still in a relational form. We also did some machine learning with Doug, who was interested in building models that predict the discharge rate for patients. We also used some ETL tools to combine all of that data and make sure that it ends up in the right place for these different components. And then we needed to add some specific data solutions for handling very specific types of data, namely the time series data and the document data, which are kind of different from how you would regularly work with relational data. So you can see that there's lots of different solutions that are really good at one particular thing. It's only in the last number of years that some of these have been starting to come together. And it differs a little bit from vendor to vendor how they've accomplished this. That trend of that convergence of the database market is also something that analysts confirm, like Gartner and Forrester. Gartner uses the term HTAP, hybrid transaction analytical processing, as sort of the combination of OLTP, online transaction processing, and online analytical processing. Forrester gives translytical as the definition to exactly the same concept. So you can imagine that when we talk to analysts, that we have to mind our vocabulary, that we're using the right terms for the right analysts. But essentially, it's the same thing. And if you remember what Nuri was doing, she was trying to dispatch patients to the right ward, leveraging a machine learning model that was built by Doug. That is a perfect example of what a translytical platform does. It's embedding analytics into your transactions. So this is really happening. There's demand for solutions like this, and as such, the market is also converging in how these analyst firms kind of present their reports. The Magic Quadrant from Gartner for operational analytical databases has emerged 2 years ago. Forrester already had a translytical Wave. Wave is the name they give to it. And they also started to issue a multi-model data platform quadrant. So in the market, you're seeing that lots of the big vendors have taken different approaches to meeting this need for converged platforms. You'll see that some have kind of really at the foundation built a multi-model flexible data platforms, and others have made pointed acquisitions and only have a priceless level integration. So you may have read between the lines that I'm not a huge fan of the approach that Dan and Cindy have proposed. So I'm actually, I love looking at what these special purpose best of breed technologies, what they bring to the table, because they often come with very interesting innovations. But I'm also a conscious father who knows the price of glue, so I'm more interested in a platform approach where there's only a single solution. And let's talk about how InterSystems Iris solves that. So let me walk you quickly through InterSystems Iris as a platform. So you may already be familiar with our core engine. So our core engine is a data engine that lives and breathes data. So at the core of this, there is this data engine where code and data are really treated the same way. So if you're writing object script code, as you well know, a variable and a stored variable, persisted data, is actually just a caret sign away from one another. And when you're writing code, really talking about core development here, when you're writing code, it's interacting with data that's only in memory and interacting with data that's persistent is exactly the same thing. So that model is really key to understanding the InterSystems Iris data platform. It gives you a flexibility that is unrivaled. And that data structure, which we call globals or persistent global arrays, is super flexible. It does not, it kind of allows you to define how you're indexing your data, and it leaves still a lot of flexibility for formatting the data. And because of that programming model in which the caret sign is the only thing that sets data in memory and data that's persistent on disk apart, you can really develop applications as if everything was in memory. And it's the data engine that will take care of fetching it from disk if it's not already cached, keeping it in cache if it needs to. So that is really what the Iris Data Platform's core data engine can give you. So performance of in-memory databases without the limitations of the physical amount of RAM that you have. So around this core data engine, we've added a distributed coherent cache. So that is powered by our enterprise cache protocol. It gives us the ability to scale out to multiple servers. And your applications will still be developed and written in exactly the same way. They will run exactly the same code, and they can expect from the platform to work through the exact same semantics that it would have if you were running on the data server itself. So it allows us to scale out in a very, very efficient way. One of the biggest Epic deployments serves 40,000 power users together concurrently on the same system, on a single system, thanks to this distributed cache. And this is still working with those variables, still at a very low programming level, but we've already already have the ability to scale out to more nodes that can still work all in the same way. It's only on top of that we finally start to care about data models. It's only here that we talk relational. It's only at this level that we talk about documents, that we talk about time series, about any of the data models that you would be interested in. And many of those come out of the box. Some of those have been contributed through or are available through the community, such as a really nice graph database implementation. And the beauty of this is that those data models, they automatically benefit from the scale that's offered by the distributed cache. So if your SQL query is running on the data server, on a data node, or on a compute node, it doesn't matter. It behaves exactly in the same way, and for the user or for the application developer, there is no difference. It's also at this level that we're adding another layer of distribution for the data itself, if there's a need. At InterSystems, we also like to take a holistic view at data management. So not just the core task that I just summarized in that diagram, but also it just doesn't end with persisting the data. Let's start with the machine learning work that Doug was doing. We believe that if you need to take your data out of the database in order to start doing your machine learning, that you're creating a disconnect. You're introducing the opportunity for your data to lag behind or for your machine learning to start lagging behind. You're kind of creating a gap that is getting in the way of proper model ops. That's getting in the way of easily retraining your models if you have new data coming in, as is likely the case in an operational system. So it also gets in the way of other parts of model ops. So for deploying a new version of your model, or being able to observe that the data is drifting from the same console. So that's why we built a machine learning capability directly into InterSystems Iris. Many of you have probably heard about integrated ML, which offers a really nice SQL interface to an automated machine learning engine that also takes away some of the data science savviness that you would need to get started. And it's a really great way to start introducing machine learning in your applications. Remember, we talked about FHIR, the standard for exchanging data between different data repositories, between these different care organizations that each have a piece of the pie of our patient records. So, well, you probably know that we've developed InterSystems Iris as a solution that lives in this disconnected world, that lives in a world where data is spread around and where you need to interoperate with different systems and servers. And those may be InterSystems servers, but very often they aren't. Very often they are systems that maybe have been around for 20 years and have these very peculiar standards and maybe aren't yet in the FHIR era. So that connectivity is also something that we put in the same solution, that we put in the same platform. And then finally, for what Catherine was talking about, she wanted to see dashboards. She wanted to see live dashboards on data that comes from multiple sources. In InterSystems Iris, there is an embedded solution for OLAP. There is an embedded solution for a running machine learning model. There is the ability to deploy virtual cubes through adaptive analytics to give you those different flavors for different kinds of analytics that you want to perform on the system. So that is really what InterSystems Iris is. It's not just data management, it's also the machine learning, the interoperability, and the analytics that provide you with a comprehensive data platform. It's a single platform, a single installation, and a single price tag. So things couldn't be more different from what Dan and Cindy were proposing. And that's not even, and there is no heterogeneity, there is no separate per product training, and most importantly, there is no glue. Okay, time to finish off with a couple of real-world customer examples to illustrate some of the customers that are using our platform in this way. So let's start with Nuri the nurse. So she was working in the emergencies department, working with an EHR system. So this is really where we have many customers, so I actually have two for Nuri, but let's first start talking about the NHS. NHS Lothian is a really big one, a really big part of the NHS in the UK that's managing 4 acute care hospitals as well as a number of other peripheral facilities in the area. In total, they serve almost 1 million patients overall. Lothian runs TrackCare, our EHR solution, that is deployed around the world. So TrackCare is a set solution, but it's an application that you can deploy, but it comes on top of Iris. And one of the advantages thereof is that you can still build on top of Iris, and that's exactly what they did. So when the COVID vaccines became available at somewhere early 2021, or maybe even end of 2020 in the UK, they were one of the earliest in Europe. So they have 7,000 people on the payroll, 7,000 people that needed to be vaccinated in the hospital alone. So those are the nurses, the clinicians, the people that work at a hospital. So being able to being able to make appointments for each of those 7,000 people, if they would go through the regular patient workflow for making appointments, it would have taken about 500 hours of call center time. In a matter of days, their engineers just built an application so that people could self-register and book their own applications. So that was a nice time win and a great illustration of the flexibility that the platform offers. Another probably better known example of an EHR vendor that runs on InterSystems Iris is Epic. They are the world's leading platform, the world's leading EHR software. And they have been around for about 40 years. So in total, it's estimated that around 250 million patients have their data in an Epic data center. This is also the example of the 40,000 power user, concurrent users that I gave earlier. Okay, let's turn to Doug, our data scientist who was predicting patient discharges. HBI Solutions is based in Palo Alto in California, right across the street from Stanford, and that's where some of their founders are still also teaching. So HBI offers risk management solutions that are working off data that's stored in HealthShare and can be employed in your patient workflows or can be applied in batch. So it's really deeply embedded, or it makes use of our platform in a really nice and really creative way. So it comes with dashboards that allow you to consult the output of these models and see those risk models in charts, but also you can deploy them to be part of the workflows and business processes that are orchestrated by InterSystems Iris. Next is Fiona, and Fiona's need was to be able to see data that comes from other locations. As you know, and as you've also heard in the presentations earlier today, in the keynotes, we have a lot of customers in this area. Health information exchanges running InterSystems software for taking care of this interoperability and taking care of sharing patient information as needed through different organizations. The biggest customer we have in this area is HealthX in New York State. They take care of about 20 million patients. 8,000 different organizations are connected through this system. So that's a massive scale. We've got other customers like them. For example, Manifest Medics has a similar number of patients, also about 20 million, but then slightly fewer organizations that are connected. As you can imagine, these networks were hugely important when the pandemic hit in 2020, and they obviously still are. So HealthX alerting infrastructure helped quite a bit, and sent in the first month of the pandemic alone 750,000 alerts for positive cases across the network to participating organizations. Catherine, our hospital CFO, was interested in dashboards. And let's maybe take a step back from the pure hospital cases and look at bioreference labs. Bioreference labs is in the laboratory business, and they offer a nice solution that offers dashboards on both the clinical and the operational side of running a lab at scale. So some of their larger deployments have BI cubes with over 2 billion facts representing real-time data from the lab. But there's other examples further afield. For example, the Shift in Brazil, who also, I'm not sure if anyone from Shift is here in the room, but they're up. Oh, hello. You're also a market leader in the Latin American market for laboratory software, also making use of the analytics capabilities of InterSystems Iris, and have managed to kind of blend it with other analytics solutions in a really unique fashion. Very nice. And then finally, we talked about Dr. Phil, who was looking to integrate medical device data with the EHR. This is what Gerbet is doing. Gerbet is based in France and the US, operating worldwide. And their contrast and care solution connects medical devices with the different other information systems in a hospital, including for systems used in radiology, such as RIS and PACS, and the EHR itself, obviously. For contrast and care, these are bidirectional flows. So it means that data flows from the EHR into those solutions for actively driving the administration of the prescribed drugs, but also the other way to track exactly how much contrast fluid was injected in a patient. This is very important because most of these contrast fluids are radioactive or are not super healthy. You wouldn't keep drinking them. So it's important to be able to keep track of exactly how many you've been injected so that we can keep using it as long as it is safe to do so, because it really helps in getting a better diagnosis, obviously, but also not exceeding the safety limit without having an unnecessarily large margin. So that is the list of customers that I wanted to talk to. It's obviously easy for me to talk about all the wonderful things that InterSystems Iris does, but I tried not to boast too much about my kids. I did boast a little bit about InterSystems, but analysts are also recognizing us for the capabilities that our platform offers, the integrated capabilities that they offer. Gartner is calling us a challenger. Their Peer Insights program is giving us great credits and ever better credits if you please wouldn't mind to show up at one of the booths and give us a review of your experiences with the software. Forrester named us a leader in their new report on multi-model databases and already has us as a strong performer for translytical databases. So, and also for class, which is specific to healthcare, we're getting some really good feedback. So it's important to keep in mind that all of these customer examples are not using Iris in an isolated way. And we were already talking about, for example, how at the NHS they were able to quickly build something on the side that was running in the same platform. Healthfix is also a customer of HBI solutions on the same system. So all of these things are all integrated. All of these things work together. All of these things run on one platform, and that is InterSystems Iris. So I'll end with something that I ask my kids on a regular basis. I'm not asking you to be less creative. I'm just asking you to use less glue. Thank you. Any questions? We've got a couple minutes left if anybody has any questions. This is a broad introductory session, so it's very timely because it's the start of the conference. There's plenty of other sessions in the various rooms around the space. Okay, well, thank you, and hope you enjoy the rest of the conference.